Welcome to the IOD403 superlab. Today we're going to be translating information into a table, graph, or diagram. Specifically, the skill sheet that you have in front of you is about translating data from a table into graphs, but you can also do it the other way just as easily. Let's get started by taking a look at the background information about how this skill is assessed. So IOD403 is a skill that requires you to look at a variety of information in certain format, such as a table or in a graph or picture. You then need to use the data and create a different format. For example, the question might give you a data table and ask you to choose the graph that you would make from the data. The question might also ask you to look at a graph and pick the data table that matches the information. A couple of hints that you'll need. When picking a graph, remember the following hints. Bar graphs are used to compare variables, so which one's the highest, which one's the lowest, while line graphs are used to show relationships between data points. When picking a bar graph, the graphs will often be missing number scales. In these cases, you just need to determine which should be the highest and the lowest, or if the bars are the same height. For line graphs, you need to determine the relationship between the data in order to determine the correct line. If the numbers are increasing, the line should go up. If the numbers are decreasing, the line should go down. And if the numbers are staying constant, the line should remain flat. Steeper lines represent faster change, while flatter lines represent slower change. Don't forget that sometimes the data can increase and then decrease, which means the line might need to move in multiple directions. The last item to look for in a line graph is the y-intercept. If the variable values begin at 0, then the line should start at the origin. If the values begin above 0, then the line should start above the origin. All right, so that's just a kind of a quick overview of what you might be looking for here. All right, the trickiest part is the thing about not having scales. All right, there's no numbers on these graphs. It's just you kind of have to eyeball it and figure out which one would make sense. So let's take a look at the passage. As we read through the passage, you should have a pen, pencil, or highlighter in your hand. As we read through it, you want to circle, highlight, or underline any word that jumps out at you as confusing, new, or that you don't know, so that we can eliminate vocabulary as an issue of confusion. Passage 2. A mineral is a naturally occurring solid formed through the geological processes that has a characteristic chemical composition, a highly ordered atomic structure, and specific physical properties. Minerals range in compositions from pure elements and simple salts to very complex silicates and can exist in thousands of forms. Density is defined as the mass per unit volume of an object. Hardness refers to the ability solid matter has to resist shape change when force is applied. A scientist investigated the density and hardness of various minerals. Her results are listed in Table 1. Did anyone have any words that jumped out at them as confusing that we should circle, highlight, or underline? Marcus? Geological. Nice. Atomic. Here we go. Nice. Silicates. Nice. Other words. We have geological, atomic, and silicates. Any other words going once? Any other words going twice? All right, so let's first take a look at the first word, geological. Remember, on the ACT and in life in general, there's 3 ways to figure out the meaning of a word. It's either defined for you in the reading, or you can use context clues and background information to figure out what it means, or you can look it up. On the ACT, we don't have a dictionary, so we don't look it up. Let's start with this word, geological. This is one of those words where the prefix of the word can actually tell you quite a bit about it. All right, the prefix of this word is geo. All right, it's not defined for us in the passage, so we're going to need to use context clues to figure out what that means. Does anyone know what the word geological means or has heard it before? What is geological? Well, this prefix geo actually refers to the earth or, whoops, there we go, the earth or rocks. All right, so geology would be the study of earth or the study of rocks. So geological is just referring to, again, earth or rocks. So a mineral is a naturally occurring solid formed through geological, so earth-based processes, and that's what geological means. The next one, atomic. All right. Again, not defined in the passage, but we've probably heard a word similar to that before. What word is at the prefix of that, or the root of that word? Atom. Yeah. All right. Atom. What is an atom? A type of, it's even smaller than a cell. Even smaller. All right. An atom is what you studied in chemistry all the time last year. An atom is the smallest amount of a substance. So when we're talking about atomic structure, we're talking about like the arrangement of atoms in a substance. Most minerals have a very regular arrangement. So anything that's crystalline, and now people at home can't really see what I'm holding up, but I'm holding up a crystal in my hand. Anything that's considered a crystal actually has its atoms all in a perfectly regular shape, and that's how crystals get their specific look. And what we mean by perfectly regular shape is that it's repeating. So like the atoms will all be, and this actually isn't perfect, but the atoms will all be right next to each other in perfect rows. And it's these perfect rows that gives crystals their specific structure. So now some minerals are crystals. Other ones have different regular atomic structures like that. All right, if we looked at a non-mineral substance, you can kind of have atoms that are loosely connected like that aren't really having that same regular repeating structure. All right, so when we talk about atomic structure, it's just the structure of atoms. And then the last word is silicates. All right, silicates is any compound containing carbon and oxygen. All right, now you wouldn't be able to tell that from this, but it's actually not super important for the rest of the passage, so it shouldn't trip you up too much. Let's take a look at the table. What we see in the table are a whole bunch of data. All right, there's all sorts of data in this table. So much data, it's actually considered a complex data presentation. It has 4 or more variables. So what you want to do right now is get a little bit more acquainted with this table by vaulting this table. All right, so flip to the back of the page. And you want to go through and vault this table. All right, use your vaulting skills to find the heading, variables, units, legends, and trends. If you're watching this at home, you should press pause now and vault this table on your own. When you are ready to go through the answers, press play. If you are pressing play at this point, that means you are ready to go through the vault together. As you can see, the heading and variables have already been filled in. You just got to kind of carefully look at this table, and it can kind of be tricky sometimes to determine, are the variables at the top or are the variables on the side? All right, now all tables will be organized either vertically so that the variables are all on top, or horizontally so all the variables are on the side. In this case, you just kind of have to use what you see in the table to make that determination. One of the things that you'll see is like a heading like this where it says density, and then you see a bunch of numbers below it. You can see the heading density must be referring to the numbers below it, and it kind of gives you an idea that the table must be organized vertically. All right, so we have all of our variables in. The next part is units. Most of these are unit lists. So mineral, there's no units. Elements, there's no units. Color, there's no units. Uses, there's no units. Density has units of grams per mil. And hardness technically has no units. All right, let's go for trends. Does anyone have a trend that they came up with that they want to share? Remember, these can be highest points, lowest points, intersection points. They can be variable relationships, any kind of trend. What trends did you have? You said as density decreases, the hardness decreases. Okay. How did you get that? So that's kind of tricky that you came up with that relationship because none of these numbers are in order. So how could you figure out that as the density decreased, the hardness increased? Okay, so one way to do this is the quick summary way, meaning you pick the highest number, which in this case is 4.3 for density. You pick the lowest number, which is 2.7, and then you pick a number in the middle. Which one'd you pick? 3 to 3.3. That looks like a middle number. And then what you try to figure out is, okay, if it's in this order where this is the lowest, second lowest, highest, based on your 3 there, does the hardness align itself with this? And so taking a look through, 7, it had the lowest density. It also has the lowest hardness. 7.8 is next, and hardness is 3. So that this would be a direct relationship. This is a great quick way to do it. All right, is to just pick 3 of them. The only thing that could throw a wrench in your plan is if you looked through all of them and there was some point that, so this line actually would go like this, straight up. The thing that would be hard is if there was some point along the way that made your line go down and back up again that you wouldn't see by doing it this way. But if we're looking at efficiency for the ACT's sake, this is not a bad strategy to use. Nice. All right. Good. Any other trends? We included the highest on here. We included the lowest on here. Anything else that anybody noticed? Any trends? Nice. That's a great one. All of the minerals listed are used as gemstones, at least as gemstones. Some of them only as gemstones, but all of them are in there somewhere. Nice. That's a good one. All right. It's kind of breaking out of the data box and going for other things. You could also say things like purple is the least common color. All right. I'm pretty sure that blue is the most common color. Yeah. So you can go through things like that. Those are all trends. Good. And then let's take a quick look at the example question then. For which of the following graphs best represents the density of beryl, quartz, and garnet? All right, as you take a look through this, which graph, is it A, B, or C, represents the density of beryl, quartz, and garnet? All right, now a fast way to get at the answer to this problem when you have a list like this is just number your list. All right, a lot of people will often just try to remember what the numbers were, but it's going to end up wasting time in the end because you'll forget which ones were which. So start off with beryl. First off, we're looking for density. So beryl density, 2.7 to 2.9, so we can go in the middle and just say it's 2.8. Quartz density, 2.7. And garnet density. Garnet density, 3.6 to 4.3 would be like 3.95, somewhere in the middle there. All right, 2 of them very close to each other, one higher than the others, and which is the only graph that makes sense? A. All right, you see beryl and quartz should be right next to each other, almost indistinguishable because there's only a 1/10 of a point difference between them, and that garnet is higher than both of them. All right, this is how you're going to tackle all of these problems. So what you want to do right now is work on questions 1 and 2, the ones with the hint at the bottom. Once you have finished answering questions 1 and 2, you can press play and we'll go through the answers together. If you are pressing play at this point, that means you've answered questions 1 and 2 already and are ready to go through the answers together. Question 1 asks, which of the following graphs best compares the number of minerals that contain specific colors? All right, the first thing that you need to see here is that we use the word compare. So which graph can we immediately get rid of if we are using the word compare? Which type of graph does not compare? Nice, the line graph. This is not used for comparison, so we can already ignore C because that's not going to tell us what we need. All right, in this case, which one is true then? Are red and blue at the same amount with more purple? Or does it go red, then blue, with the least amount being purple? B. Nice. It is this one. And a great way, you could do this a couple of different ways. You could certainly just number each of them. In both cases, we're comparing red, blue, and purple. So maybe you just go through and actually count them up and write in the numbers. The other thing you can look at is you'll notice that purple, in this case, is the big difference between the two. All right, purple is either more than the other two in this case or less than the other two in this case. So it might even be faster to go through and say, okay, well, if purple's the big difference, how many purples are there? None, 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 1. Compared to reds, which are 1, 2, 3, and blues, which go up to like 5. I think I might have missed a red in there too. And so knowing that, you know that purple's the least, and it actually saves you a little bit of time, and you can automatically just go for B.
So like if it says a blue green, do you count that as one or no?
In the Oh, I get what you're saying. So like this one right here where it's blue and green, I believe that was counted as blue because that would have been 5. Would have been blue, 2, 3, 4, 5. Yep, if it has a little bit of blue in it, that's what they were referring to in this passage. All right. Number 2 works a little bit differently. You're not counting and comparing in this case. In this case, you're looking for the general relationship. All right, general relationship means we aren't going to use a bar graph that compares things, but we don't have any bar graphs to get rid of. So if we look at the 3 different graphs that we could be comparing, they're all telling us different things. If A was true, what relationship must be true? As hardness increases, what happens to density? Decreases. So this one is saying as hardness increases, density decreases. The second one is saying as hardness increases, what happens to density? Yeah, increases and then decreases. Whereas the last one is saying as hardness increases, what happens to density? Just increases. So now we can go through this, and we had one student kind of give us a shortcut already to try to find, if you just pick the highest, the lowest, and one in the middle, that was quartz was the lowest, diamond was the highest, and then we said tourmaline was in the middle. You can find already that which one is automatically not true. A. You know that A isn't true from the quick version of looking and saying, like, okay, well, the smallest one has the smallest hardness, and the highest hardness has the highest density. So we know that this one can't be true because that doesn't follow that relationship. And so the tricky part here is that either one of these could be true because you don't know about this data point unless you actually look at all of them. All right. The other fast way to know that it's not B is because of the way, again, this shortcut relationship where it was 1, then 2, then 3. All right, you'd expect the 2 and 3 to maybe be flipped if it were B. All right, the last thing you could do is actually go and number them all and put them in order if you wanted to do it that way. This is a big table. That might take you a long time, though. All right, so in this case, C is our answer. At this point, you have 2 questions left. Answer questions 3 and 4, and then press play when you want to go through the answers. Notice there's no hints here, so try your best. If you are pressing play at this point, that means you are ready to go through and check the last 2 questions, questions 3 and 4. Question 3 says, which of the following graphs best compares the number of minerals that contain specific elements? All right, now the nice thing about this question is all 3 graphs are comparing the same thing. It's always carbon, oxygen, silicon. Carbon, oxygen, silicon. Carbon, oxygen, silicon. All right, so all we have to do is write in numbers and we can figure it out that way. All right, how many of them contain carbon? Go over to the side. 1 contains carbon. And that's it. How many of them contain oxygen? In this case, we have 1, 2, 3, 4, 5, 6, 7. All of them except for diamond contain oxygen, so we put a 7 there. Last but not least, how many of them contain silicon? 1, 2, 3, 4, 5. All right. In this case, if we take a look at these 3 numbers, they only make sense in one spot. They don't make sense over here. All right, because you wouldn't expect carbon and silicon to have bars of the same size. They don't make sense here because you wouldn't expect carbon to have a bigger bar than silicon. But they do make sense right here because carbon's the lowest, oxygen's the next, and oxygen's the highest, and silicon is in the middle. Which makes our answer C. Last but not least, which of the following graphs best represents the general relationship between density and hardness? And now this is the tricky part of the minerals used only as abrasives. So in this part, we get to ignore a whole bunch of our graph. All right, we are going to only concern ourselves with the things that are used as abrasives. That means we get this one's an abrasive, that one's an abrasive, so we're going to highlight this row. And there's one more. This one. And this one. Computer-generated straight lines. Nice work. Okay, so now we only care about these four. All right, we can do the same tactic we did before with numbering them. Which one in this case is the lowest? Which one are we starting with? Density. So let's go density. Quartz is the lowest density. Which one's next? Yep. Garnet's next. Which one's next? Corundum. And highest would be diamonds. Now let's hope our other ones go in the same direction, and that would tell us something. Or if they went in an opposite direction, that would tell us something different. All right. So in this case, if the other ones went 1, 2, 3, 4, which graph would be true if this were the case? The first one, because what is this is showing us is that as our blue ones increase, as our density increases, our hardness would then decrease. But in actuality, that doesn't happen. What really happens is, all right, a replication of what we saw before with 1, 2, 3, 4, which makes which one true? C. As density increases, the hardness of substances used as abrasives also increases. At this point, it is time to take a quiz. If you understand all of these questions, you are ready to take a quiz. If you don't understand a question, now is a good time to rewind back, look at the part that you are unfamiliar with, go back over that. And if you are ready to take the quiz, good luck.